Now, whenever you're relocating large pieces of equipment, I mean, especially if you're talking about, hundreds of feet of automated equipment, how do you ensure that when you realign those, they're realigned perfectly? At Elite Automation, we design systems to be very modular, whether it be simple small systems or whether it's large scale, huge manufacturing lines that scale hundreds and hundreds of feet. Now, how are we able to do that? We're able to do that through this modular process and through creating systems and creating different stations and different work envelopes for the different equipment to live within. This gives us the ability to create all the programming, all the electrical engineering, and everything to be in a very systematic design that gives us the ability to have these modular systems. These modular systems also give the ability to grow into the future. So whenever you have these modular systems, you can add on to the modular systems over time. So maybe you start off with some smaller investment of a few $100,000, and then you're able to move into the second phase of a project without additional cost of PLCs and some of the other hardware that may have went into the initial cost of the system, and be able to expand to additional parts of the system without as much of a cost, and also just keeping the same infrastructure and the ease of deployment of that next phase of that system. This also gives the ability for fast line changes. So if you need to add different adaptive pieces of equipment to the system, or modular pieces of equipment to the system, you can add them in and out of the system. A lot of times these pieces of equipment are on a base where a fork truck can come in and pick them up and take them out of the cell. Now, this is again for smaller operations. This wouldn't be your huge automotive type of operations, but even automotive operations that are more of your assembly line type of automation, these can be designed on these platforms where they're able to be moved around and shipped very easily. Using these modular type systems that are easily broke down and moved around gives you the ability to have them in one location and then in another in a short period of time. Sometimes with zero programming changes or any modification needing to be done to the system at all. So you might have a system that's in Mexico that you need to ship to the US, right? Due to these tariff issues. So you ship that system to the US and start manufacturing in the US almost immediately. And then say, for instance, if tariffs go away, you can shift it back to Mexico and start deploying that system in Mexico very easily. And this is something that a lot of companies are not taking into account, and this is something that can really drive companies to thrive in business, honestly, because what they're able to do is shift around due to the different economics and different tariffs that we have within different countries. So say, for instance, in the US, we're struggling to employ people, then it might make sense that we move from Mexico to the US because we need to give more jobs to people here in the US. And maybe there's some incentives there for companies to employ people in the US. Maybe there's grants, or maybe there's just other business incentives for employing in the US. Again, right now it's tariffs. That's the big one, is tariffs. So by shifting around and having a system that has the ability to shift around, you just overall have more strength and more dynamics in your company because you're able to move these systems depending on how the economics of things are moving. And going into like the nitty and gritty about the tariffs, it's a lot cheaper to move an automated system from location to location and pay tariffs against it than it is to produce parts in a specific area. So let's say, for instance, you have $1 million automation system and you want to move it from the US to Mexico, or Mexico to US, the cost of that tariff is going to be much, much less. And also, I'll get into some other things as well, but also your cost for producing a part that you're going to then ship to an automotive company. Let's say you're an automotive manufacturer and let's say you're producing seats. Then that seat is going to be produced in Mexico and then shipped across the border to the US. And with that being said, the total amount you're going to pay on tariffs is going to be much higher than the amount that you're going to pay on the automated system to ship to the US. Now, to get back to the other thing, is you can actually get a little bit creative whenever it comes to shifting automated pieces of equipment from one place to another. Why is that? Because the value of that automation system is really dictated doesn't really have a good appraisal value, right? So it's hard to value a piece of automated equipment. You could value it at its material cost, and at that point, a material cost of $1 million system might only be worth $100,000. You can say, oh, this is like somewhat useless piece of equipment. We're going to repurpose it in the U.S. for some other thing, blah, blah, blah. And so since that is an appraisal type of thing, it's hard to say like what the actual value of that system is. Now you could have PO values and you could go off those PO values, but some of that portion is engineering. It's not the hard product you're giving. So you're able to also take like a system that might be $1 million system and get it across the border at $250,000 because of just the nature of like the product and what the product is worth, especially if it's a product that you've had on your manufacturing floor for multiple years. You've been able to depreciate that asset for some period of time, and now you can take that depreciating asset and send it to the US at a reduced cost. So I want to dive in a little bit on what do these systems look like. So these systems might be systems that are built on platforms where they're able to be picked up by a fork truck. They might be built on systems that have like eye bolts, so they're more easily able to be rigged, I mean picked up with a crane or also a fork truck, some other lifting piece of equipment, and also on a firm enough structure that they're able to be picked up, right? If it's designed on a thinner sheet metal or just a thinner plate of steel, it might not be able to be moved around in the way that it could if you have like a 1-inch thick piece of steel as your base plate. So you have to take your platform into consideration, and then you also have to think about your mechanical relocation into consideration. So your mechanical relocation would be if you separate two pieces of machinery and you put those pieces of machinery back together, how are those pieces of machinery located in a way that ensures that the alignment is perfect? Now, whenever you're relocating large pieces of equipment, I mean, especially if you're talking about, you know, hundreds of feet of automated equipment, how do you ensure that when you realign those, they're realigned perfectly? And the way you do that is through locators. So you have to have mechanical locators, and a lot of times you'll see mechanical locators in manufacturing processes. You don't necessarily see them on the equipment themselves as equipment alignment products or features, but in the systems we deploy systems that, or can deploy if it's an option to add that, is mechanical locators where, let's say you have two pieces of conveyor. Those conveyors can be mechanically relocated to each other so that way they're in exact alignment. Instead of having to run a laser line and measure and pull a center point off of both conveyors and just hoping whoever does that process does it right. And I'm just giving conveyors as a generic example because a lot of times, you know, conveyors have a little bit more tolerance to be off. But if you're talking about like robotics and robotic placement and fine-tuned placement, then you need that placement to be fine-tuned. So with the locators, you can essentially plug those conveyors back into each other mechanically, and also, let's move on to the next thing, electrically. So you can have the mechanical and the electrical plug connectors built into the same module, so that way after the mechanics line up and plug in, you then have the electrical connectors that it can plug in. Now, again, depending on how much cost you want to spend on the system could be where you mechanically align things, plug things in, bolt them to the ground, and then electrically plug them in at a further process, manually just doing plug connectors. However, it should be minimized to just plug connectors. There should not be any hardwired connectors. So anywhere where there's a split in different pieces of hardware, there should be a plug connector. And the other thing is you should also have your communications also being plug connectorized. So all your communications should be set up in a way so that each system is its own communication device. You should have remote I/O that's on each individual conveyor, so that way that conveyor lives as if it's its own separate piece of hardware. All your robotic cells should be their own separate piece of hardware. Even if everything runs off of one PLC, one main brain, everything also has its own separate hardware. Now, you can't have everything have its own PLC. However, the caveat to that and the challenge with that is that now you're increasing your cost. So now every module has to have an additional $3,000 cost for each individual PLC on that system. Whereas you can do cost reduction and still have one PLC for the entire length of the system, and have like that master PLC that controls all your logic and all your safety I/O, and just have individual IO on each individual station or fixture, or depending on your operation. There's so many different types of manufacturing processes. It's hard to like really dive into each individual one, but just think of everything as like an operator type of station, or an automated station, or an automation cell, a robotics cell. These are all different types of ways to frame the different hardwares that may be there. And also too, how much hardware is on the particular device. So if you have a conveyor with one sensor on it, then maybe it doesn't have to have its own communications. Maybe just a plug connector for a sensor is fine enough. And then maybe you have other systems where you have 20 sensors on one conveyor. And so something like that makes sense, that you have an IO module directly on that conveyor to control it. And maybe you have the motor and its drive and everything directly on that conveyor. And so then you just give it its supply power and its communication, and then it's ready to go. So if you guys have any other questions, make sure to drop them down below. Anything regarding like tariffs, automation systems, and how we can develop systems that'll help you be future proof and help you get through these tariffs and really just remain profitable. And a lot of companies are struggling to remain in business. Make sure to give us a call, email us, contact us down in the comments below, and subscribe, because we'll be producing more content like this, and we'll catch you in the next one.